So uplink profile is simple. Did you say something?
No, no.
Okay. So uplink profile is basically it tells to the NSX-T from a host. We have NIC card, right?
Yeah.
Server will have a NIC card, maybe a 2-port NIC card or 4-port NIC card or whatever it is. So this uplink profile will tell to NSX-T how these NIC should be used for the NSX-T functionality, or the different parameters we will be setting to the NIC cards will be specified, because this is the ports which is getting connected to your physical switches. Okay, so we are going to define those details. So on the GUI, once you log in, system, then fabric and profiles. So we have different type of profiles. You can see here, you have uplink profile, NIOC profile, edge cluster profile, edge bridge profile. So there are a lot many. Okay. So what we are going to see now is uplink profile. Under uplink profile, you will have few uplink profiles already created. It is built in, right? When you deploy the NSX-T manager. So if you want to create additional uplink profiles, then you will click on add. You click on add, you will get this pop-up window. So here it's asking for a name. Then if you want to use a lag, what is lag?
Link aggregation.
Link aggregation.
Great.
Right? If you are using a LACP protocol for bundling multiple links of your server, then that you will specify here. Okay. Otherwise, if you are using normal teaming, then that you will specify here. Okay. Then here you are saying,
yeah. Yeah, this uplink profile for this north-south connectivity towards
no.
leaf.
Towards the leaf,
Oh,
yes. Towards the leaf.
towards the leaf.
Nodes are connected to the switches. So
Switches.
these links, how it should be used?
Okay, it's for then in that case it's a north-south connectivity, right?
No, it is just a physical connectivity. North, south, or east, west is based on what is the traffic which is flowing in the network. Okay, so
Then
if from the same node, if you are sending a traffic to other server, it is east, west. From the same node, if you are sending a traffic to outside world, that is north, south. This is a traffic what we are calling. The flow of data is what we call it as east, west traffic or north, south traffic.
So this uplink port can be used for both.
For both.
Can be either north-south or can be both. It will be used for
Yes.
east-west traffic also. It's
Same
north-south
NIC.
traffic.
Same NIC will be
Uh-huh.
sending or receiving east-west traffic or north-south traffic.
Okay. So this lag is for teaming, right? This NIC card teaming
Yes.
or specific
It is for NIC card teaming. If
team.
you have a LACP configured on the switch side, then on the node side, you will configure this lag.
Okay.
Lag configuration will support LACP protocol. Okay, so if switch side is LACP, then this side also should be LACP. Otherwise, link will not come up.
Okay.
Now we are specifying something called a transport VLAN. What is transport VLAN? See, yesterday I told you from the nodes, inside the node we have multiple VMs, right? And these all VMs, when it reaches to the node, so that is node means server, the servers are acting as VTEP or TEP. So what is mean by VTEP? Tell me.
It is a virtual tunnel endpoint, right? So
Tunnel endpoint. Right.
tunnel endpoint.
So we have tab The servers are acting as TEP. Every server is a TEP. So what he does, he is doing VXLAN encapsulation and decapsulation. Right?
Okay.
So
Yeah.
the normal Ethernet traffic, when it reaches the node, this Ethernet traffic is getting an additional header of VXLAN. Then on top of that, we are getting a Ethernet header added. And it is going out to your next layer switch. If it is access AG, it is going to the AG switches. If it is a spine leaf, it is traffic will be forwarded to spine switches. Whatever it is. What is the traffic? Outer header is Ethernet. Ethernet means it is going as a normal packet which where the VXLAN is not visible to anyone. So if we are sending Ethernet traffic, this will be part of any VLAN. So through which VLAN I will send this packet or this frame. So to carry the encapsulated VXLAN encapsulated frame, we need to send it through some VLAN, then only it will go to the other side. Which VLAN will carry this VXLAN encapsulated traffic to other devices is what we are specifying in transport VLAN. Simply, it says which VLAN we will use to transport our encapsulated traffic from one device to another device.
Okay. This again, it's a east-west traffic.
No, again I'm telling east-west is the traffic which is flowing. Okay. So this VLAN, he will carry the traffic. He don't know whether it is a east-west or north-south. Both traffic can go through this VLAN.
Okay. Okay. From server to server, the VXLAN tunnel will be get established, and then
Using this
traffic will
VLAN,
be
right? The tunnel is
using
getting
this VLAN.
established, right? So how the tunnel is forming? Those tunnel traffic is passing through this VLAN, 113 VLAN.
113 VLAN. 113. Okay. So again, this tunnel will go via leaf switch, or how it will be? This tunnel.
Tunnel will be going, see, whatever you have physical path, through that only your traffic can go, whether it is tunnel or your user traffic or whatever it is. So how is the physical connectivity you have? It is like this, right? You have connection from here to here, here to here, here to here. So if your user traffic is going from here to this VM, then this will use this path. Or alternatively, it can use this path also. If it is east-west. If it is north-south, again it is using the same path, but it will go to edge node. From the edge node, it will go outside.
So in that case, this VLAN need to be get configured in the leaf switch also.
On the leaf switches also, yes.
Okay.
Okay, if you don't know more in detail about spine leaf, don't think about spine leaf and complex it, think about access AG network. That is simple, easy to understand.
Access, yeah. Correct. Access.
Right. So,
Some switch.
yeah, so in this case, this 113 VLAN must be configured on all your physical switches. Your whole network infrastructure must be configured with 113. That is the prerequisite.
Transport VLAN. Okay.
Yes, transport VLAN must be configured on your physical infrastructure, and that VLAN you need to give it in NSX-T. If I say, if I tell to NSX-T, you use 113 VLAN, and if the network don't have 113 VLAN, then what will happen? NSX-T cannot send the traffic, right?
Yeah.
So this is the only one VLAN you need in your physical infrastructure for sending your traffic. Doesn't matter how many subnet you have, how many IP group you have, doesn't matter. Just one VLAN is enough on your physical infrastructure. Clear? So we are specifying what is our transport VLAN we want to use for sending the encapsulated traffic. Then we are saying, what is my MTU? What is MTU?
Maximum transmission rate.
maximum transmission unit. That means what is the maximum size of a frame which can be passed through your network. Okay. Normally it is 1518 including your header. 1500 byte is your actual frame, and on top of that 18 bytes of header will be there. So total a frame can have 1518 byte. But now what is happening here? We have a additional VXLAN header is getting added. We have a additional Ethernet header is getting added. So this will not be the default size, right? So the frame size is increasing more than 1518. That is the reason we are telling to NSX-T that okay, you can the frame size can be up to 1600 byte. That means again your physical network infrastructure must be enabled with MDU as 1600. So when NSX-T sends 1600 byte of data, your switch also should know that okay, I need to support this big size of frame, otherwise the frames will be dropped. Okay, so two configuration on your network infrastructure. One, you need to set your MDU. Second, you need to configure one VLAN for transport purpose. Clear?
So the VTEP IP that will be on a VXLAN header, right? The VTEP IP on the server.
VTEP IP address will be on your VXLAN header.
VXLAN. Okay.
Or we can say, so it's not exactly like that. So how we do this is your original Ethernet. Then your VXLAN and header is getting added. Then your UDP header. Then your IP header. Then your Ethernet header. This is the actual. If I see inside, this will be the structure. So this IP address will be your tunnel source IP and tunnel destination IP. That is your VTEP IP addresses. Source VTEP and destination VTEP. Yeah. And inside this Ethernet, there will be IP header. This IP header will have the source and destination, actual source and destination who is communicating, this VM IP address and this VM IP address, source device IP address and destination IP address.
Okay, okay. Inside VM IP will be there. It is
Inside the
encapsulated.
VXLAN header. And this is for your VXLAN purpose. So source and destination will be your TEP devices.
Okay. Then VTEP. What is that Ethernet one? The top one?
This one.
Yes, yes, yes.
This is the Ethernet frame. By looking into this, see, once it is encapsulated, where the traffic should go? It should go to the other tunnel endpoint, right?
Tunnel endpoint MAC address.
This step MAC address will be there in the Ethernet header. Source will be this step MAC address. Destination will be this step MAC address. Here in this Ethernet header, source will be the source VM's IP address, and destination MAC address will be destination VM's IP address. Sorry, MAC address.
Okay, okay.
Is that clear?
Yes. So before that, ARP will be get resolved, right? Then only
Yes.
it will send the packet.
Yes.
Okay.
Yes.
Got it. Yeah. Thank you.
Those are normal, whatever is happening in the normal networking, those all activities are required here also. All right. So now we specify all these.
I'm writing it. Just a minute.
Okay.
Yeah, you can go ahead.
Okay. So once we give all these parameters, then we will say add. When you click on add, that particular uplink port group will be added here. Okay. So you will get a additional entry. And this port group, this uplink profile can be used when we configure our host preparation, when we do our host preparation. So two things we did now. One, we define the transport zones. Two type of transport zone. One is overlay transport zone, and another one is VLAN transport zone. Right, that we defined. Second, we created a uplink profile. This will tell how the NIC cards of your node need to be used for your NSX-T purpose. Right?
Yeah.
So there are two type of, yeah, I think quotation. Two type of
Question?
transport zone. One is VLAN transport zone. What is the other one?
Overlay transport zone.
Overlay.
Overlay transport
So
zone is for your VXLAN traffic, and VLAN transport zone is for your VLAN traffic.
VLAN transport zone for VLAN traffic, and
Overlay transport zone for your VXLAN encapsulated traffic.
Okay. So right now we discuss, right? It is a VLAN transport zone.
Transport zone was yesterday's topic. Today what we discussed is only the uplink
transport
profile.
VLAN. Okay. Okay.
What we discussed now is transport VLAN, not transport
VLAN
zone.
Zone.
Any question?
Koteshwar Rao asking.
No, nothing from my side.
Okay.
All right. Now, I told you our ESXi servers are acting as TEPs, who is doing the encapsulation and decapsulation. And just in previous slide, I told you in the VXLAN header, this is your original Ethernet, then VXLAN header will be added, then UDP header, then IP header, then Ethernet. Right. So in this IP header, what is the source and destination? The source TEP device's IP address, and destination IP address will be destination TEP device's IP address. So that means inside your host, when he do the encapsulation decapsulation, he is using a IP address which is actually doing that encapsulation forwarding the traffic, right? So what is that IP address? From where they will get the IP address? That also we need to define. So that is what we define using our IP pools. Okay, so till now what we configured is in system tab. Now it's IP address configuration. It is networking part, right? So we'll go to the networking tab. Inside that bottom, you will see IP address pool. And we have here IP address pool and IP address block. So you select IP address pool and click on add IP pool. So it will ask for a name, and here it will be 0 when you do for the first time. If you click on that, you will get this new window open. So here you can add your IP address. Okay, so you can define your IP address range. Then once you say OK, you can save it here. Okay, simply here we are saying a range of IP address which can be assigned to these devices when NSX-T manager does the host preparation. So when he install the modules to this server, he will assign one IP address also to him. From where? From this IP pool, whatever we are configuring here. Simple, right? Any question?
Yeah, for there are some individuals, right? Like Ethernet, IP, UDP. So for them, the IP pool can be, I mean, these can be assigned to some IPs, right? I mean,
Your
yeah.
Ethernet is layer 2.
Okay.
Packet is your layer 3.
Okay.
Segment, that is your TCP or UDP, that is your layer 4. Okay. So only your layer 3 need IP address. This is your port number. This is your MAC address.
Okay.
So once you prepare your host, you need an IP address for communication, for the TEP functionality. So what NSX-T manager will do, he will pick one IP address from this subnet and he will allocate it to this step. And he do next host preparation, he'll pick another IP address and he will assign it. From the pool, he will assign one IP address to each device.
Okay, got it.
What is VMK port or VMK NIC? What is VMNIC? What is VMK NIC?
VMNIC is nothing but virtual machine NIC. I mean, virtual NIC of a VM.
Virtual NIC of a VM. What is VMK NIC?
There is a uplink NIC.
You have a server configured with ESXi or installed with ESXi. How do you access that server from your PC? This is your PC, you are sitting here. This is your switch. So your PC is connected to the switch and switch is connected to the server and server have ESXi installed. How do you access this ESXi in this PC?
I think our diagram is okay. ESXi.
So with that ESXi IP slash UI in the
So you
address
will
bar.
type the IP address of ESXi, right?
Yes, yes.
In the browser.
Yeah.
Now tell me, where is that IP address on this server? Where you are configuring. When you assign a IP address during the ESXi installation, where is that IP address is getting configured?
Yeah. Can you repeat the things?
See, when you install your simple question, straightforward. Okay. When you install a ESXi on a server, it will ask for IP address, mask, and gateway, right? So we are giving the IP address for that particular host. My question is, where is that IP address getting assigned?
Some DHP server.
If you have a laptop and you are assigning an IP address, where is that IP address getting assigned? Your laptop will have a NIC, correct?
NIC.
Yes. Physical NIC.
And this IP address is getting assigned to the NIC.
Oh, okay, okay.
If you have two port, you can assign two IP address, correct? Because you are assigning IP address to the port. So each port can have its own IP address. My question is similar to this. If you are doing an IP address assignment on on ESXi, where is that IP address getting stored or assigned. Is it on NIC?
Yeah, NIC only. Yeah.
It is on NIC?
Yeah, it's on NIC.
It is not on your NIC.
Oh. VMK NIC. Okay, then in that case, some software. VMK NIC.
Which software? Where?
VMK NIC virtual VM NIC. VM.
The physical NIC can be used by this ESXi.
No.
VMK NIC.
Inside your ESXi,
That's what we are installing that ESXi in the physical machine, right? So the physical NIC card will be used by ESXi when we install that.
it will be used, but not IP address assigned there. Okay, so when you install ESXi, you have a vSwitch 0, right? vSwitch 0 will get deployed automatically when you install ESXi. And on your vSwitch 0, you have a port group.
Correct. Port groups.
VM port group, VM port group, and VM kernel port group.
Yeah.
So you have VMK0. VMK0. This is a virtual NIC, or we can say virtual adapter on your vSwitch 0. This interface is actually getting that IP address. Okay. And your server will have a NIC card, 4-port NIC card. These NIC cards are connected to the vSwitch 0. These NICs will not have any IP address. Okay. So this is like one switch is getting connected to, right, from the server the ports will be going out and it will be connected to a physical switch. So that is the reason the server NIC cards are called uplinks. It's acting like a switch to switch connection. That is why we created uplink profile. We said how the uplink need to be used. The previous slides we discussed about uplink profile, right? We said how this NIC need to be used. There we didn't specify any IP address, right? So your IP address, when you install ESXi, IP address is getting assigned to your VMK0. Like this, you can create n number of VMK ports, VMK1, VMK2, VMK3, and you can have n number of IP address also. So anytime if you deployed a data center, then you will be aware you will have a management IP address. You will have another interface for your vMotion functionalities. You will have another interface for your storage access, NFS or CFS access. Like that, you have multiple interfaces for multiple purposes. So one ESXi can have multiple IP addresses. Fine.
Yeah.
So using this IP pool, at the time of host preparation, I said one IP address will get assigned to the each node, right, for VTEP functionality. So this IP address is getting assigned to VMK10. So NSX-T uses VMK10 interface on your nodes for using it for VTEP functionality. Fine. So you learned a new thing about ESXi today, right?
Yeah.
Okay. There are a lot of small things. Okay. As and when it comes, we'll discuss. Okay. Next is transport node profile. So what are the things we discussed? One, we discussed transport zone. Second, we discussed uplink profile. Third, now we discussed about IP pool. Okay. Now fourth, we are going to discuss about a transport node profile. It is nothing big. We are going to bind all these informations, but we need to say, right, we can have multiple transport zone, we can have multiple uplink, we can have multiple IP pool, but when I do the host preparation, I need to tell out of these things, which are the things which I need to use for the preparation. For that purpose, we are using the transport node profile. Transport node profile will pick one transport zone or two transport zone uplink profile, IP pool, and other parameters required for your node preparation. So transport node profile defines different parameters need to use for the transport node preparation. Okay. All right. Transport node profile gives the power of speedy deployments and avoids any manual error. What is this? See, the previous class, I told you I can prepare individual hosts one by one. So what happens? Every time I need to tell what is the transport zone I need to use, what is the uplink profile I need to use, what is the IP pool, and all other parameters I need to tell for each and every node. So I'm repeating it. So the configuration task is more. I may create manual errors when I do that. To avoid that, we are creating a transport node profile. And now onwards, whenever I do a host preparation, I will simply say use this transport node profile. No confusion, no mistakes. Okay. Okay. So from 3.0 with 7.0, vCenter or ESXi 7.0 and NSX-T 3.0, we have an option to use distributed DVS switches, which is part of your vSphere, or you can use the older way of using NVDS for the networking functionality. So we have both options starting from 3.0 version. Okay. And edge clusters, still they can only use NVDS. Okay, newer version will confirm it. So as I know, till now this is using NVDS only. Maybe they introduced in recent version, I'm not sure. Okay. Okay, coming to the transport node creation. So we are again going to the system tab. Here on system tab is there, fabric, profile. Then you will have a transport node profile here. Okay, inside. This is the first tab, second tab, third tab. That's the transport node profile. So when you click on add, we'll get this window. So here we are giving a name for the transport node profile. I'm saying transport TNB, transport node profile, ESXi. Any name you can give. Your name also you can give, not an issue. Okay. Now, whatever the transport nodes you, transport profile, sorry, transport zones you created, those all will list out here. You can take that and you can click on this arrow, so it will be selected. So this box is for selected transport zones. Okay. Your normal nodes, transport nodes, except your edge node. We discussed it in the previous class. So normal transport nodes need only overlay transport zone because they handle only the encapsulated traffic. But your edge nodes are talking east-west, right? They are handling east-west and north-south traffic. Both should come. So VXLAN traffic will come here. They need to do encapsulation, decapsulation. When the traffic goes out, they need to do the VLAN handling also. So these nodes will have your overlay transport zone and your VLAN transport zone associated. Okay. So now we selected only overlay transport zone. Now we'll say add. So we'll go to the second tab. So in second tab, what are the options? We have many things to set. One, we are giving the NVDS switch name. We are giving a name to use for the transport zone switch. Then NIOC profile, network IO control. These default profiles are already there. That's why we are not creating it. There is no reason for us to modify it. And uplink profile we saw, we are selecting that uplink profile which we created. LLDP profile, we already have default LLDP profile, so we are just calling them. IP assignment. So we can say use IP pool. When you use IP pool, here drop down, you can select what is IP pool you need to use. And here we are saying what are the physical NICs we are going to use. We will say VMNIC 2 and VMNIC 3. Right? Those are mapped to uplink 1, uplink 2. Then other informations are not required. So when we see these all what we configured before, right? We created uplink profile, we created the transport zones, and we configured the IP pool, and all those things we are mapping or we are defining inside your transport node profile. We are making a relation between all these things, and we are saying add. We say add, that transport node profile is created.
Shomar, I have one basic doubt. What is the difference between transport node and the edge node?
Edge node is also a transport node means any device who is actually doing the TEP functionality in simple terms. Okay, so any device who is handling your who is doing your TEP functionality is your transport node. So here encapsulation decapsulation is happening. Here also we have so many VMs, right? And this is edge node. Edge node also, right? When he receives the VXLAN traffic, he is doing the encapsulation and he is sending additionally VLAN. So these all devices, these all we call them as transport nodes.
Okay.
And edge node is also a transport node, but as he is involved in north-south traffic communication also, that is the reason we are calling him as edge node, because he is sitting at the edge of your data center. After this, it is going outside your data center. So transport node is of two type, a normal transport node, or we can say this is correct. So transport node, a normal transport node or a edge node, or we can say nodes are of two type. One is transport node and another one is edge node, but edge node is also a transport node.
Yeah. Okay.
So we defined our transport node profile. Now what is that we need to write? We need to use this transport node profile and we need to prepare our nodes. Okay. So on your UI, we are going to system nodes. There you have host transport node or edge transport node. Okay. So if you have your vCenter server integrated with your NSX-T, then you will have an entry like this, which is your vCenter server. Or you will have only this entry. If you don't integrate, if you don't have an integration with vCenter server, then only standalone host it will show. If you use standalone host, then for each and every host, you need to keep on giving all the parameters manually. That is very tedious. So easiest way is select your vCenter server, integrate vCenter server, then select your vCenter server. So once you do that, it will list out all the clusters you defined inside your vCenter server will be pulled to NSX-T manager, and it will list out. It will show all the things. See here, we selected same page. Okay, so system fabric node, and under host transport nodes, we are selecting the vCenter server. Once you select the vCenter server, See the clusters, edge cluster. There are 3 nodes, 3 servers. And compute cluster. There are 3 nodes. It will show all. These are, we didn't configure any of this. We didn't say that, okay, these hosts are existing. But he pulled all those details from the vCenter server and he is displaying here. Now, very easy. You can simply tick the cluster. When you tick the cluster, all 3 nodes inside that is included in that, right? Then click here, configure NSX.
Okay.
So you will get this pop-up. There what you are doing, you are just selecting the transport node profile. This is the name we created, right? TNB ESXi. We are just defining, saying that use this profile and prepare this cluster. When you say prepare this cluster, prepare all the nodes under that cluster. Now you will say save. When you say save, see, you will be able to see the status here. It will take some time. Okay. So it will show it is doing installation, it is doing that configuration, this, that, multiple things you will see. And finally, you will see success and up.
So
Straight to your
these three.
cluster,
Mhm.
straight to the cluster, it will show how many hosts are up, how many hosts are down.
Mhm. So these are cluster edge clusters, or this one are normal
This is the normal clusters,
normal VM. We are
normal host transport node, not VM. These are the ESXi nodes.
okay. 3 ESXi nodes. Okay. And then we are making as a transport node.
This is the edge node that we are not talking now. So we have a cluster. This cluster is your workload cluster.
Workload cluster.
Workload cluster, where you have your
So,
VMs are running, your what services are running, web server, database server, all those things are running here. This is all ESXi. Edge node is also ESXi, but we are not talking about edge node now because that is in a different cluster. So we just selected this workload cluster and we did preparation. So these 3 nodes under this is prepared. Now I need to select the other cluster. So what is other cluster? See, edge cluster is there. If you select that and you say configure NSX and select the profile, save, then it will do the preparation for other cluster also.
So there are 2 type of clusters. One is a workload cluster, that is a ESXi. That edge also it's a ESXi, right? Then there is a edge cluster, workload cluster and edge cluster.
So you understand one thing, don't confuse. There is a possibility for a confusion here. These clusters got nothing to do with your NSX.
Okay.
This is pulled from your vCenter server, right? It is pulled from the vCenter server. So whatever you configured in that vCenter server, that will display here. Not only 2 cluster, you may have 20 cluster for different purposes you may have. All those 20 cluster it will show here. Okay. So what the cluster name here it is saying edge cluster, right? That name doesn't matter. Here it is saying compute cluster, name doesn't matter. In NSX-T, which cluster we are planning to use it as a transport node, which cluster we are planning to use it as a edge node, that will be actually acting as transport node and edge node. Okay, so this is just what we configured in the vCenter server. So normally when we do it, we will give the cluster configuration according to what we are going to do in the NSX-T. So if you think in that way, that is correct, but it need not to be right exactly matching with the terms what we are using in NSX-T. It need not to be on your vCenter server.
Okay, workload cluster and edge cluster.
So here you will see the transport zones assigned to those devices. Here it will show the NSX-T version, which is that I told you, right? Host preparation means what? You will be installing different modules into this ESXi's. You will allocate an IP address. You will create a NVDA switch, that is a NSX-T functionality switch will be pushed into the host. Then there will be a connection communication established from your NSX-T manager to this. If manager cannot communicate with this node, then there is no use, right? So there will be a communication established between them. So all these preparation, all these process after that, you will see status success. Okay. Now, how do you do? Now what we saw is how do we prepare the host transport node. Now we are going to see how do we prepare for your.
Hello.
Yeah.
Okay.
So similar to what we did for transport zone, we can we can select the other clusters and we can do the ESX installation. So for a edge cluster, if you have 5 nodes, these are prepared, right? How we prepare it. We need not to prepare these edge nodes, not required. Why? Because these are the ESXi nodes, but they are not actually acting as edge. We will deploy a VM on top of that, and that VM is actually acting as a edge node. So when you deploy edge nodes, automatically he will have all the VTEP modules, all those information, everything will be available here. Okay, we will see that. All right, some verifications. So if you go to your transport node, if you go to your host transport node, then if you click on the right node under that cluster, you select that, you will see a switch virtualization section. If you click on that, you will be able to see the new NVDAs created, the TEP IP address allocated. Okay, so this information you will be able to see. See here, VMNIC0 is mapped to your vSwitch0. This is your physical adapter. And VMNIC4 is mapped to your DV switch. And NVDAs is showing here with the TEP IP address. And you can see another DVS with another uplink. So how many switch you have, how you did the NIC mapping, that you will be able to see in this switch virtualization section. And if you go to your vCenter server, see, this is not NSX-T UI. This is your vCenter server or vSphere client. So if you go to the node, if you select the server, go to configure, go to virtual switches, you will be able to see here, DV switch, standard switch, and VDS. This is for NSX. Okay. So which switch you select, that switch diagram it will show below. So now this is expanded, right? Arrow is below, towards down. So this showing, it is showing now NVIDIA switch details. If you click on vSwitch 0, then here you will see the vSwitch 0 diagram. You select this, then you will see a DV switch diagram here. And if you go to your server, again configure. Previously we verified virtual switch section, right? Now if you go to your physical adapters, then you can see the NICs which you selected is mapped to your NVDS. Okay. Now, if you select VM kernel adapters, VM kernel adapter is what? I told you inside ESXi, the virtual adapters, virtual interfaces, which is getting the IP address assigned. That is the VM kernel adapter. You select that, then you will see VM NIC 10. See VXLAN, right? VXLAN means your NSX-T functionality. And the IP address, this will be from the pool which you created. This will be one of the IP address from your pool. Okay, so whatever we configured, we can verify it inside your vCenter server. Any question? Okay, from the NSX-T UA also you can see the same thing, your NIC details. From your transport node section, if you select your node, there you will be able to see transport node status, network interface. So if you select the network interface, you will be see the network details. Again, this is same. If you select the TCP IP configuration section, TCP IP, so see, we verified virtual switch. Next, we verified a VM kernel port, physical adapter. If you select the TCP IP configuration, then you will see there is a TCP VXLAN protocol stack is installed. This is packet capturing. Okay, so how is your VXLAN header is? See, how do I explain this? This is a Ethernet header, IP header, UDP header, user datagram protocol, right? UDP header, and your on top of that you have your VXLAN. Right. And again Ethernet, and again IP, and this is ICMP. So this is not a normal data communication. This is, I think it is a capturing from the ping packet. That's why you have ICMP. Okay. So this is your original data. On top of that, VXLAN header is added, then the UDP, then the IP, then the Ethernet. This is what we discussed, right? Yeah. But I drawed it like this. This is my original data. Original data means I just showed Ethernet. But inside Ethernet, what do you have? You have your data, actual data, then you have your UDP, then your IP header, then your Ethernet header. This is the actual full original data. Then on top of this VXLAN header, then your UDP, then your IP header, then your Ethernet header. Same thing, no? But only thing is it is showing in on top of, and I showed in right line. That's it. Okay. Yes. I told you, right? The host preparation will push many modules, VIPs into the ESXi. See, ESXi software web list, and I'm grabbing using NSX keyword. So these all are the modules. These all are the modules which is getting installed as part of your host preparation. So once these all modules are installed, and once they start running, if they can make a communication channel established between your NSX-T manager and this node, then everything is good and fine. So this is a communication. This is not important. Okay. So this is what is happening internally. So how these different components are talking, what is the port number they are using, all those stuffs. This is not important for us. That's it. Host preparation is over.
Okay.
So what are the steps? See, we'll start from the beginning. Okay, the whole thing I will explain. So we have a normal ESXi vSphere installed data center there in the data center. What we are going to do is we are going to prepare that data center for NSX-T functionality. So what is the first thing we need to do? We need to deploy our NSX-T manager. How you will deploy? Your normal OVA deployment procedure, what you did in ESXi classes, right? When you learned ESXi. So you will deploy using OVA, you will deploy your first manager. Now, what is recommended? We need 3 managers, right? So additional managers, you have 2 options. One, same procedure you deploy using OVA 3 times, then manually put them into cluster. These are all manual tasks. This is one way. Or second way is you integrate your vCenter server, your NSX-T manager. Once you integrate the NSX-T manager, vCenter into NSX-T manager, third, log in into your NSX-T manager, and from there you can say deploy additional appliances. So 2 more click, you will get additional 2 more vCenter. So this is easy. These 3 VMs will be 3 NSX-T managers will be deployed. Automatically NSX-T manager will take care of the cluster configuration, the syncing between them, everything, and finally it will show the status app. Okay. So now your NSX-T manager is ready. Now what is next? We need to do the host preparation. For doing host preparation, that means preparing your nodes for doing NSX-T functionality, we need to do some pre-configurations. What is that? One, you need to define a transport zone. Second, you need to define uplink profile. Third, you need to define IP pool. Fourth, you need to define transport node profile. Then fifth, log into your UI and you say do the transport preparation, right? Transport preparation, you will say host node preparation, you will refer this transport node profile and your host will be ready. That's it. Over. This is what we discussed till now.